So last time we have seen some examples with if, with the command if. Let's see some other example scripts. This example is very similar to the last one that we saw. It is testing an integer, and it is making different checks. Is it less than 0? Is it even or odd? And so on. But the only difference is this special construct here with this double bracket square. This is another way to make a test, and it has some small differences with the ones that we have seen so far, which is basically the command test and a single square bracket. One advantage of this construct is that it allows the usage of regular expressions. With this operator, we can check whether a string is matching a given regular expression. So this is a regular expression. If you remember, this is matching the beginning of the line or the beginning of the string. This is matching the end of the string. So basically, this regular expression is matching the whole string. And we are trying to check whether this is a regular number or not. Is it the value in the variable int is the correct number or not? So we have a minus, which is optional. This question mark is showing that this character can be in the string or not. In both cases, it will match. And then here we have a digit from 0 to 9. And this plus is at least 1. So we have at least one digit, and it can be possibly prefixed by a minus here. So if the content of the integer of this variable int is matching this regular expression, then this is a correct number. Otherwise, which is the part at else, we are displaying this message int is not an integer, and we are displaying it to the standard error, and we exit the script with exit code 1, which means error. And the rest of the script is the same. We are checking whether it is less than 0, negative, otherwise positive. We are checking whether the remainder of division by 2 is equal to 0. If so, we are printing the message integer is even, otherwise it is odd. So let's test this script. Int is negative, int is odd, and this is correct because int is -5. If we try to edit the script and then change it, for example, to 11, and test the script again. In this case, the message is int is positive, and the messages are int is positive and int is odd. Let's try another number. Int is positive and int is even. Let's try with 0, for example. Int is 0. And let's try with this. And now we get this error message, int is not an integer, because this ABC here does not match this this pattern, and so we go to the else part, and we display this error message: int is not an integer. Another benefit of this construct is that it can match with using pattern matching, the same that the path name expansion does. For example, if we have a file, so this is a variable, and we are giving this value to this variable. Now we check whether file is equal or matches foo dot star. Then this is a kind of matching that is done by shell expansion. For example, when I say ls foo dot star, then shell is expanding this pattern to match all the files in the current directory that start with foo and then a dot and then anything else. And the same kind of expansion is done here. This is expanded by the shell, and then it will see whether the expanded string is equal to this variable. So we cannot use this kind of construct with this single square bracket that we have seen before, but it is possible with this one. So this is one of the advantages of this construct, this testing construct, compared to this one. So it is another advantage. The other one was that it can use regular expressions for matching. Now we can use another kind of testing, which is suitable for arithmetic expressions. Let's see an example. So here we have this double parentheses, and inside double parentheses we have an arithmetic expression, and this arithmetic expression evaluates to 1 in this case because it is just the number 1. And now if in arithmetic expressions and usually in programming languages, 0 means false, and anything different from 0 means true, which is the opposite of what the shell does. In shell, if we have a 0 exit code, this means successful, which is kind of true. And if the exit code is different from 0, this means failure or error, which is like false. And in other programming languages and in Boolean logic, it is the opposite. But this arithmetic construct makes the conversion. So if the arithmetic expression inside the construct is true according to Boolean logic, then this will be successful, and it will return a 0 exit code. if the arithmetic expression inside is 0, then this will be a failure. It will fail and it will return a failure. So if this is 0, then this return a failure. It is converting this false arithmetic value here to failure. So since this is false, then this echo is not executed. The echo after then. And if there is something different from 0, then in arithmetic logic or in Boolean logic, this means true, and this is converted to success. And so this echo is after then is executed. Let's see another example that is using this kind of construct. So we'll see this example, test integer to a. It is similar to the previous example. We are checking here whether the integer variable contains a correct number. And then here we are doing the test of the value of integer using this arithmetic expression construct. And inside the arithmetic expression construct, we can use the name of the variable without the $sign, and it will be replaced by the value of the variable. So we are checking whether integer is equal to 0. If it is equal to 0, then we print this message integer is equal to 0. Here we check whether integer is less than 0. So this is an arithmetic comparison, so which is used in arithmetic expressions. Then integer is negative, otherwise integer is positive. Here we get the remainder of divider by 2 and check whether it is equal to 0. So let's compare this with the previous script to see the differences. So this was used for checking whether it is equal to 0 in the previous example, and this is what we use in the second example. So if, we use this minus EQ to check whether it is equal, whether this is equal to this one. This number is equal to this one, and we use this equal sign to check for equality inside this arithmetic construct, arithmetic expression. We use this minus LT or little to check whether this number is less than this number, and we use this angular bracket. So this is seems more natural and more easy to understand. So if we have to compare two numbers, then it is better to use this construct rather than this or the other one with double square brackets. And if we actually test it, we will get the same result. So they are identical, almost identical. Now let's see another example. This one, test integer 3. And in this example, we are trying to find whether a given number, a given integer, is within a specified range of values. So this is the number, and this is the minimum value, and this is the maximum value. And we are trying to test whether this integer is between these two values. First of all, we are checking whether the given integer is correct as a correct number value with this regular expression pattern matching. We have seen it. And this exclamation point is not. So it reverts the result of this checking. So if this matching is successful, then this not makes it false. If this matching fails, then this not makes it true. And in this case, we will print this error message, and then this exit will terminate the script. The script execution will stop, and it will exit with this exit code. Now here we are checking that here we are checking that the integer is greater than the minimum value, and integer is less than the maximum value. And with this construct, we use this logical operator, double ampersand, for AND. So this AND is true when both of these expressions are true, or if this succeeds and this succeeds, then the whole expression succeeds. So if both of these conditions are satisfied, then we print this message: integer is within minimum value to maximum value. Otherwise, we print the message integer is out of range. And now we check the same thing here, but we are using a different kind of logic. We are using this not operand. And because we want to revert the result of the whole expression, we are using this parenthesis. So we are closing the whole previous expression in parentheses and placing one not operator in front of it. And now notice that the message is different. The message in the previous example is within the range. Here it is, the message is outside the given range. And also the else message is out of range, is in range. And this is because this not is reverting the result of the whole expression. Now the same checking, but using these arithmetic operators, arithmetic expression construct. And here starts the construct, and here ends, and everything inside is considered as an arithmetic expression. And so we are not using the $sign here for the names of variables in front of the names of the variables. And we are using these operators, arithmetic operators, greater, smaller. And again, this is the AND operator. So the AND operator is the same in both these cases. And also the NOT operator in front of the parentheses is the same. So we are grouping some parts of expressions with parentheses, and then using this not operator in front of it. And now the same checking using this test construct. So here is a single square bracket and a closing one. And now the not operator. And here we have parentheses. But because this is parsed by the shell and the parentheses have a special meaning to the shell, we are escaping with the backslash, the parentheses. Otherwise, the shell will interpret them as something else. And for comparing two numbers, we are using greater or equal and less than or equal. So greater is GT minus GT. Greater or equal is GE. LT is little, and LE is little or equal. And as logical operator AND, we are using this minus A. So this is stands for AND. Whereas for the other constructs, we were using this logical operator. So let's test it. $50 is within 1 to 100, and using these operators, 50 is in range, 50 is in range, 50 is in range. So we did it using different kinds of testing operators. Now, these logical operators and can also be used to combine two commands. For example, command 1 and command 2. And the result is that if command 1 is successful, then the command 2 will be executed as well. We can also have this OR operator. And in this case, if command 1 fails, then the command 2 will be executed. If command 1 is successful, then the command 2 will not be executed. This is called lazy evaluation of logical expressions. So this OR logical operator is true if both parts are true, or if both parts are successful. So if this command is successful, the bash has to check whether this command is successful as well, in order to evaluate the whole expression, to find the value of the whole expression. But no, the opposite. If this fails, then it has to check this one as well. But if this is successful, then the whole expression is automatically successful, so it doesn't have to check the other part. So the command 2 will not be executed. So let's see some examples with this. For example, this is a command that is going to create a directory, and then this is a command to switch to the directory. So make directory temp and switch to directory or go to directory temp. So if this command is successful, this command will be executed as well. But if this command fails, then this command will not be executed. So we end up to this directory. This is the same as writing if make directory temp, then cd So this one is equivalent to this if. If this command is successful, then execute this command as well. But if this command fails, then this command is not executed. And in this case, this command fails because the directory already exists. And so the cd command is not executed in this case. We can write the same example or a similar example like this. If the directory temp exists, so this is a test that is checking whether the directory exists. Directory temp exists or make dir temp. So we are checking first whether the directory exists. If it does not exist, then we execute this. The bash will execute this command, make directory temp. But if it does exist, then this command will not be executed. And this example is equivalent, or it is the same with this if directory temp exists, then do nothing. Otherwise, so if this command is successful, then do nothing. This column is a null command. A null command in bash means a command that does nothing. But we need to write this command, otherwise there will be a syntax error. So if there is nothing at all, then just empty space. This gives a syntax error. So if we want to say just do nothing, we use this null command. So otherwise, if this command, if this directory does not exist, it will create it. So this construct is equivalent to this if else. So the scripts that we have seen so far just have an int variable that we are changing manually. We edit the script and we change it, the value manually, in order to test the rest of the script. But it would be more convenient if we can read it from the keyboard. And this example shows how to read something from the keyboard. Let's have a look at this example. Read integer, evaluate the value of an integer. So this echo is printing this string. And this -n means don't print a new line after the string, because by default, echo prints a new line after each argument. Or at the end of printing, it also prints a new line. But this -n shows don't print a new line. And then we have this command read. This read is going to read something from the keyboard until we press enter. And the thing that it gets from the keyboard is saved into the variable with this name, integer. And then we go on and check whether this is a valid number. And then we check whether it is 0 or not. Is it less than 0? Is it even? And so on. It is the same kind of testing that we have seen before. But what is different is that we are not using a fixed value in the code of the script, but we are reading the value the number that we are going to test from the keyboard. So let's check how this works. please enter an integer. It is this message here printed by the echo, and because of this -n, we don't get a new line at the end of the string, so we can continue inputting something here. Now let me say 7 and then press enter. At the moment that I press enter, the line that I typed is saved into this variable, and the rest of the script is checking the value of the variable. Let me try it again. Now I give another number, and let me try it again. 4 is positive, 4 is even, -5, 5 is negative, -5 is negative, -5 is odd, and another number, -8. -8 is negative, -8 is 8 is even. And let me say that I give something that is not a valid number, and it will say the message input value is not an integer. So this is more convenient when we read the value of a variable from the keyboard. The command read can also read multiple values and save them into multiple variables. And this example shows how it is done. This example. So here we have the prompt message, enter one or more values, and then read. We are going to read up to 5 variables, var1, var2, and so on. And then we just display the value of the first variable, the value of the second variable, and so on. And let's see how this works. It meant enter one or more values. So the shell is reading this line when I press enter. When I press enter, it is getting the line, and then it is splitting the line by empty spaces. And the first part is assigned to the first variable. The second token is, or the second string, or the second part of the string is assigned to the second variable, and so on. But what happens if we have more than 5 variables, or more than 5 words or tokens? So we have 5 variables, but we have more parts. So the first part goes to the first variable, the second part to the second variable, and so on. And when we go to the last variable, then it gets all the rest of them. And if we actually give less than 5 variables, then the rest of the variables are just empty. Let's see another example with read, which shows some other features of the read command, or some other options of the read command. So let's see this example, read user password. So we are trying to read a user password, and the command read here has these options -e and -p. This -p is for prompt. So this string here is displayed as a prompt before it starts reading from the keyboard. In the previous examples, we used an echo before the command read to display the prompt, echo -n and then the prompt. But it is also possible to use the option -p to display a prompt for the command read. And this -e is used to tell read to use read line to get the input. Read line is a library that allows to move back and forward with arrows, for example, or to when we press Ctrl A, it goes to the beginning of the line that we are typing. When we press Ctrl E, it goes to the end of the line that we are typing. And this is done by this library, read line. So if we use this option -e, then while we are typing the input, we can go back and forward with Ctrl A, Ctrl E, or we can move with arrows and correct some parts of input and so on. And this option -e is used to provide a default reply. So this is the variable that we are going to read. So we will the command read is going to say the answer or the input to this variable, and we are using this as a default variable. Default variable is if we just press enter. So no input. We don't give we don't type anything, but just press enter. So if the input is empty, then it is going to use the default value for this variable, and the default value in this case is this environment variable user, which is the current user. And after we get this the reply into this variable, we print this welcome message, welcome username. So this is reading the username. Now this part is reading the password. We have another read command here, and this -t10 is timeout. Timeout 10 seconds, which means that if we don't press anything for 10 seconds, then the command read will stop waiting, and the script will continue. And this -s. The option -s is for silent. Silent means that do not echo characters to the display as they are typed. So when we type the password, nothing is shown on the screen, on the display. And this P is the same. It is displaying a prompt. So this is the prompt. Enter your secret passphrase. And the value of the input is stored into this variable. And this command is also used with this if. And if the command is successful, then it is going to display this message: your secret password is secret pass. But if the command fails, when does the command fail? The command fails if there is a timeout. So when the timeout is reached and no input is given yet, then the command is stopped and it fails. It returns an error message. So I couldn't get any input, an error message. In case of error message, then we display this error message, input timed out, and we return with an exit code of 1, which means error. There was some error. And this echo, this -e option of echo is makes this /n a new line. So it is treating this \n as a new line. Without -e, it will be just -n as a part of the string. So let's try this test, this command. What is your username? And here it is supplying the default value. Okay, let's use the default value. I'm pressing enter. Welcome, user 1. Enter your secret passphrase. I am typing something, but it is not displaying anything because of the option -s, silent. So while I am typing something, it displays nothing. And 10 seconds went by, and it timed out. So I did not type it fast enough. So let me try it again. And when it times out, then the command read fails, and then this part is executed, input timed out. So let me try it again. User2. Your secret passphrase is 123. Let's see this other example with read. And in this script, we are reading something, a username, into this variable. And this is the prompt, enter username. Okay. And now we use grep, the command grep, to take a line out of this password file, the line that is starting with this username. So we get just one line from etc password, and we store it into this variable file info. If file info is empty, which is tested by this -z option, -z or zero length, then no such user. It means that it did not find any matching line in this file. And then the script is terminated. The script is exited with an error code. The rest of the script does not execute, is not executed because exit terminates the script or finishes the execution of the script. But assuming that this is not empty, then this test will fail, and then this code will not be executed, and the script will continue to execute the rest of it. Now, in this line, we have the command read. This is the command read, but in front of the command read, we are defining a variable, IFS. And IFS stands for internal field separator. And internal field separator is used to split the input and then assign the parts to the different variables of the command read. By default, input field separator is either an empty space or tab or new line character. So each of these characters will separate the input, will split the input into different parts. But in this case, we want to split or we want to use as a separator this column. So we are defining this variable before executing the command in the same line, as the command, in order to modify the value of this variable temporarily. So we modify the value of this variable just for this line, and when this line is finished, then it will get it will have the old value again. This environment variable is going to have the old value again. And now there is another thing that we have not seen before, and this is called here string, and it is it is similar to a here document, but for a short input. So a here document, we have just two of these, and then we have we have a token, and then several lines of input, and then a closing token. But if we have three Angular braces or less signs, then it means that the rest of the line is considered as input to this command. And it will split this line using this column, and then different parts will be assigned to these variables. And the rest of the script just displays the values of these variables. So let's execute this script. Enter username, user1. And it is getting with grep it is getting this line from etc password, which matches at the beginning the username that I am providing here. And then this line is splitting it. The command read is splitting it into different variables, but it is being split by columns, not by empty space as usual. So if you check the value of IFC, let's do it like this. It contains empty space, new line, and tab. So usually the read will split the line that is given as input by empty spaces. But if we do this in front of the command, then it will change it temporarily to this character. And it is the same as doing saving the old value. So when we define a variable in front of the command, it is the same as saving the old value, changing the value to the new one, and then after this line is executed, then the value changes back to the old one. For example, old So we save first this value, and then we define a new one, and then we execute this command read. With some input, for example, and then we restore the old value. So this is the effect of you defining a variable in front of a command. It is changing it just for the execution of this command, and then after the command is executed, the variable will still have the old value that it had before. So let's try to execute the script again. I'm using a variable that does not exist, a user that does not exist, then it gives the message no such user. Now let's see this example script that is used to validate its input. To validate an input means to check whether it is correct or not, whether it is within some boundaries or and so on. So here we are defining a function, invalid input, which is just displaying this error message. It is displaying it on the standard error and exits with an error exit code. Then the script continues by reading something, and usually we have a variable where the read is going to store the value that it reads. But in this case, we have no such variable. If the variable is missing from the command read, then it is going to store it to the global variable reply. So after this command is executed and we provide an input from the keyboard, the input that we provide is going to be stored to the global variable reply. So we check whether the reply is empty. And if the reply is empty, then we call the function invalid input, which is this function. And when this function is called, it will also terminate the execution of the script with exit, and it will not continue to execute the rest of the script. But if the reply is not empty, this test will fail, and this will not be executed, and then the rest of the script will continue to be executed. Now we are making another test here, and if this test succeeds, again invalid input function will be called, which will terminate the script. Now what are we testing in this part? Echo reply is piped to word count minus W. So we are counting the number of words in the reply, and if the number of words in the reply is greater than 1, then we say invalid input and we stop the script. So we just expect 1 word as an input, and actually we are expecting the name of a file. So we are checking here, is input a valid file name? So we're using this testing construct in order to use this regular expression pattern matching. And here there is a regular expression that matches a valid file name. So a valid file name may contain a minus, an alphanumeric character, letters and digits. It may contain a dot or an underscore. So if it contains some of these characters, it is a valid file name. And if the test fails, then at the end we have this echo string reply is not valid file name. But if it does match this regular expression, then it is a valid file name, and then we print this message is a valid file name. And we continue to make some other tests. -e, file exists. If the test succeeds, then we print file exists. Otherwise, we print file does not exist. Or if it is if the input is a floating point number, we are checking whether the input is a floating point number, and again we use regular expressions. And a floating point number may start with a minus, an optional minus, so it has this question mark to make it optional. And then we have either 0 or more digits. So this star means 0 or more digits. And then we have this dot. We are using a backslash in front of it to escape it, so that it just represents a dot. Otherwise, a dot can match any character. And then after the dot, we may have one or more digits. This plus means one or more, and then digits. So if it matches this regular expression, then we print the message is a floating point number. Otherwise, it is not a floating point number. So a floating point number, it has a dot and some digits after the dot, and it may not have any digits before the dot, or it may have some digits in front of the dot. Or is the input an integer? We are checking whether the input is an integer. An integer is one or more digits. This plus means one or more digits. And then if it is a negative number, it can contain a minus in front of it, an optional minus. If it does not contain a minus, then it is a positive number. So let's test this script. Enter a single item. X is a valid file name. Yes, it is a valid file name. However, file X does not exist. Okay, does not exist. It's not a floating point number. It's not an integer. Let's try it again. Enter a single item. Is a valid file name. File food.txt exists. Is not a floating point number. Is not an integer. Yes, we have this file here, so it does exist. If we test it again, enter a single item. Let's say is the valid file name because it contains digits and a dot. A file name can contain digit and a dot. A file name that contains digits and a dot is a valid file name, but this file does not exist. Is a floating point number. Is not an integer. Let's try it again. Is the valid file name. File does not exist. Is not a floating point number. Is an integer. And for the last time, invalid input. Invalid input because I'm giving two items. And actually, I can also make an invalid input by using some characters that are not allowed in a file name. It's not a valid file name. So this is not a valid file name. Let's check this other example as well. Menu.sh. A menu-driven system information program. The command clear is erasing everything on the display on the screen, and then the command echo is displaying this menu with some options, with options 1, 2, 3, and 0. And if we press 1, we want to display some system information. If we type 2, we want to display disk space. With 3, display home space utilization, and with 0, just quit. And then to read the input, we use the command read with this prompt, enter selection from 0 to 3. And then we check the reply. if the reply is matching this regular expression, which means from 0 to 3, if it does not match, because this is the negation operator, then we print the error message invalid entry and then exit the script. And if the reply is actually equal to 0, then we terminate the program, display the message program terminated, and then exit without exit code, but the default exit code is 0, which means success. The program terminated successfully. And if reply is equal to 1, then we display the host name and then execute the command uptime, which will give the information that is requested by the first item of the menu, and then exit. We exit so that we don't continue to check the rest of the script. We don't continue to execute the rest of the script. Because if the reply is equal to 0, for example, then it cannot be equal to 1, it cannot be equal to 2, and so on. It doesn't make sense to execute the rest of the script. So we just do whatever action is requested by the reply, and then we exit to stop the execution of the script. And in case that the reply is 2, we run this command to display the requested system information. And in case that the third option is selected, the reply is 3. In this case, we make this distinction, another check. If ID minus U is the ID of the current user. If it is equal to 0, then the current user is the super user, is the root of the system. And then we display the home space utilization for all the users with this command. Otherwise, the user is just a normal user, so we just display home space utilization for the current user using this command, du minus sh, and then home. So let's check this menu program. Please select display system. Let me try 0 first. Program terminated. Okay, let me call it again. Display system information. And it is displaying the host name and then the output of the command uptime. With 2, display this space. This is the output of the command. 3, display home space utilization. It is just displaying the utilization of the current user. And let me try to use another option that is not valid. Then it is giving the error message invalid entry. So this is for the day. Let's stop here, and we will continue on the next lesson.